Have a good vibes to everyone who watching this video. Today I am going to explain and show how to solve word problem about equilibrium, which had a two condition. Now we're going to start in first condition of equilibrium, where first condition of equilibrium is that net force in all direction must be zero, or if the sum of all force acting consequently on a body is equal to zero, then the body must be in static equilibrium, where summation of net force is equal to zero. So let's start with case number 1. Word problem is: the sign below hung outside of the science classroom, advertising the most important to be found inside. The sign is supported by a diagonal cable and a rigid horizontal bar. If the sign was a mass of 50 kg, then determine the tension in diagonal cable that support its weight. This picture shows the illustrate of our word problem. Now let's find the tension. Solution is: since mass is 50 kg, the weight is 490 Newton. Since there is only one upward pulling cable, it must be supply all the upward with approximate 490 Newton of force. Thus, tension force is equal to 490 Newton divided by, since 30 degree is equal to 980 Newton, so the answer is the tension in the diagonal cable that supports its weight is 980 Newton. Case number 2. Word problem is: a cat with a mass of 10 kg sits on the carpet on the floor. How much force is exerted on the cat? Solution is: since the force exerted on the cat is the normal force, we're going to use the equation 9.8 meter per second squared for the gravity. Our formula is normal force is equal to mass multiplied by gravity. So normal force is equal to 10 kilograms multiplied by 9.8 meter per second square. So the answer is the normal force that exerted on the cat is 98 Newton. Resting in your hammock, a 68 kg person lays in a hammock. The rope at the person head make angle of 40, the horizontal, while the rope at the person feet make an angle of 20. Find the tension in two ropes. Solution is: since we will be dealing with force, it is convenient for us to express the mass of the person as a weight immediately. That is, weight is equal to mass multiplied by gravity, which is
680 kg
multiply 9.80 meter per second square is equal to 688 Newton. All the force that are acting on the hammock are drawn in figure B. The force which I show you. The first thing we observe is that the hammock is at rest under the influence of several force and is static equilibrium. Thus, the first condition of equilibrium must hold, settings the force in the x direction to 0. Submission of force. X component is equal to 0. Ambition of force, X component is equal to tension 2X component minus tension 1X component is equal to 0. So tension 2X component is equal to tension 1X component. And this become tension 2 cosine is equal to tension 1 cosine. Taking all the force in the y direction and setting them equal to 0, which the component become this. To solve for tension 2 at this point, because tension 1 is unknown, equation tension 2 is equal to tension 1 times cosine divided by cosine. Tension 2 can be determined if we substitute this equation to tension 2 into equation. Substituting the value of W equals to 668 Newton cosine 20 degrees and coefficient of friction 40 degrees into our equation, we find the tension I as tension 1 is equal to 668 Newton divided to the sum of sin 20, cosine 20, and tangent 40 is equal to 668 Newton divided by 1.13 is equal to 591 Newton. Next, substituting this value of tension 1 into equation. Tension is equal to tension times cosine divided by cosine of coefficient of friction is equal. Tension is equal to 591 Newton multiplied by cosine 20 divided by cosine 40. The answer is 752 Newton. The tension in each rope is different, that is tension 1 is not equal to tension 2. The rope that are used for hammock must be capable of withstanding those tension or they will break. Case number 4. A particle of mass rests on a 37 inclined plane, a 5 kg with the horizontal. The surface of inclined plane is assumed to be frictionless. Identify the magnitude of the force exerted by the inclined plane on the box. Solution. Summation of the force in y complement is equal to normal force addition to mass multiplied to gravity multiplied to cosine 37 is equal to 0. You will use cosine because it is inclined plane. Normal force is equal to mass multiplied to gravity multiplied by cosine 37. Normal force is equal to 5 kg multiplied by 9.8 meter per second square multiplied by 0.79. Answer is normal force is equal to 43.61 Newton.
Second condition of equilibrium, sum of torque acting on a body is 0.
A force of 250 Newton is exerted on a cable wrapped around a drum that has a diameter of 120 mm.
What is the torque?
Reduced about the center of the drum. Notice that the line of action of the 250 Newton force is perpendicular to the diameter of the drum. The moment arm is equal to the radius of the drum. Radius is equal to diameter divided by 2, which is 120 mm divided by 2 is equal to 60 mm or 0.06 meter. The magnitude of the turkey, if around Lloyd equation is turkey is equal to radius force, which 250 Newton multiplied by 0.06 meter is equal to 15.0 Newton negative m. Finally, we determined that the sign of the turkey is negative because it tends to cause clockwise motion about the center of the drum. Thus, the answer is written as T is equal to negative 15.0 Newton negative m. Case number 2. A little baby boy is sitting on the edge of the seesaw that is a balance at the end. The seesaw is 8.0 meter long and the fulcrum, which acts as the pivot point, is at the midpoint of its length. If her mass is 15.0 kg, find the torque that he applying. Solution is torque is equal to force multiplied by lever. That is our formula. Now, torque is equal to 15 kg multiplied by 9.8 meter second square multiplied by 4 meter. We will use 4 meter because he is at the end at a seesaw from the fulcrum. The answer is the amount of torque that he apply is 588 Newton